Welcome our speaker, Mr. Michael Tsui, CEO of Rehab Robotics Company Limited. Welcome, Michael.
Thank you very much, and thank you for the invitation from Global Source. So the reason I'm here, I think it is because of the product right here. This is the robot hand, and we apply this for the use of rehabilitation training for stroke people. So it is a product we put it on like a glove, and then there is something behind this. We have other sensors to detect the EMG signals, the muscle signals from the patients. So when a patient he suffers from stroke, he will have some symptom to live with. So basically he cannot control his hand. So my background is occupational therapist and an engineer. I didn't really practice in the hospital, but before I joined this commercial world, I practiced like 2 years in an elderly home. So at that time, I see a lot of people, they suffer from stroke and the after symptoms. So when maybe you come across some people, they suffer from stroke and they recover and get back to their home, but they have problem with their hand and their foot. So basically they cannot control their hand. So you see people, this is the symptom called crawl hand. So we collect 20 people from the Polytechnic University. They suffer from stroke, and then we give the instruction, and then we ask, could you open your hand for us? We attach 2 sensors on the extensor side, which means it is going to use for opening the hand, and the flexor side, both sides. It should, for normal people, if they want to open the hand on this side, on this direction, we should see the signals from their extensor side. We see also signals from the patients on the extensor side, but that is not same level of magnitude compared to the normal persons. But when we say, could you try harder? And then we will see the patient close their fist harder. When comparing the signals, we see the signals from this side increase, from the flexor side increase, from the extensor side it didn't increase too much. So that's why we come with an idea for using a robot and their residual muscle signal to make a product to train up their hand. So when you look at the history of robot application of robot technology in rehabilitation, everyone, if you come across a physiotherapy training, so you see a physiotherapy on the right side, the patient is on his left side, on her left side. So she assists the patients walking by giving assistance as they need it. And later, we have some kind of robot, but we offer passive training. But hand off is different. So it is what we call the active assistive. So we detect the patient's intention to move the hand, and then we move along with his or her intention. So since like 30 years ago, there are already many robots appear in the market. And in 2008, we have this idea. I go back to Hong Kong Polytechnic University, and then I tell my professor, say, hey, there are nothing in the market which focus on hand, which is also my focus for the patients. How about we make a robot hand to assist the patient's training? And benefit of using robot for the training, because the training would mean like similar as when you want to lose weight and you do exercise. You cannot do it like one day. you need to do it like every day. And the more you do, the better benefit you get it. So I think and before why robotic application for rehabilitation only appears the recent 30 years. I think before we want to get the proper position for the movement. So we want to control the range, and we want a lot of repetition. And we want, of course, we want to reduce the attending time for the physiotherapist. That would mean also cost. And then, yeah, high repetition is the key. And something make us distinct from the other robotic training, because we extract the intention from the patients. So this is a theory actually even before 50 years before we made this. So there are a lot of publications about how nerve is going to recover when it is impaired. So the neuroplasticity, plastic surgery. So plastic means it can be changed. So neuroplasticity means when compared to the concept people have 50 years ago, people think when your nerve impaired, when your nerve die, it died, it's gone. But neuroplasticity is a term that describing what is going to happen when your nerve has been impaired, how we can encourage the recovery of the nerve. So it is basically setting up a new pathway for your command. When you suffer from stroke, it is either here or there, most people. So it is the motor area controlling the movement. So every command of movement is generating from here. When we have this region impaired, we lost the ability for our brain to send a command. But the nerve pathway is all intact. We still have the whole pathway connected by our original nerve cell. The only problem is the commander there. So we need to assign another area in our brain to give this order of the movement. But how? How to encourage this neuroplasticity? We understand there are only two things we need to remember. First, we need to, of course, as I said, we need to encourage the people to do exercise, a lot of repetition, not one, but many. And then second is we want to recruit also. We don't want to use completely passive method to move the patient's hand. We want him to participate, but how to extract? If the case, the people cannot move, even you ask them to move, how you can detect their intention? We use sensors. So we need to understand the intention of the patients, and then we ask them to participate by sending the signals to their muscles. Even though it's not a lot, but our electronics would magnify it, and we do a lot of signal processing, and then we understand the movement direction. Many times it is different from his manifestation. So this is the concept of how hand of hook work. So the brain is sending signals through the motor nerve to the muscle, and our sensor is there. And then the robot will move along with the signals. And then this is also giving a feedback for the patients. And later on, we believe this is in line with the theory of neuroplasticity, and this is encouraging recovery. So that is so far how many we sell, and we receive a lot of inquiry from all over the world. So of course from Hong Kong and Macau, the nearest place, and also from China. and Taiwan, Singapore, Middle East, US, and several countries in Europe. So right now, it is the user in Hong Kong. So this is all the facilities. They are having major patient source from stroke. And recently we helped launch our rental program. So from this hospital, there are only 44 hospitals in Hong Kong. So not every hospital, like the Hong Kong record, is also one of the 44. So many of these hospitals, they are not focusing their surface on stroke rehabilitation. So this is very much all the hospital, they have rehabilitation for stroke. So if we sell this to Rehabilitation Institute focusing on stroke, I would say this, our market has been saturated. That's why we now, and we see also many cases when patients, they need to go to as an outpatient, they go to the rehab center. They need to take a long, like 1 hour transportation, and the same 1 hour way back. And the rehab center may offer them only 45-minute trainings. And when you talk to these patients, they say, okay, I'm not sure if this is the best benefit of me. And then we also launched last year some pilot rental program to let people use it at home. The concern is if they are using at home without supervision, will it still work? And we get quite positive result. So we also do some promotion in our minibus. This is the detail of our rental plan. We also have a booth, but not here, but in the hall 2. We have a booth. You can, this is not a complete system, but if you go there, you can have a try on our system. And we have people, Christina will be there waiting for you. So this is our clinical findings. So when this is my experience, and of course we understand how it works. When you make an industrial robot, most of the time you may spend on the technologies, how to make it work, and then marketing, and then you have no other barrier for marketing. But if we claim this is indicated for using in stroke patients, this is a class 2 device in China, class 1 in US, and class 2 in Europe. So different countries, different regions, they have their regulatory requirement for medical equipment. So clinical is part of the things we have to take care. So in our company now, we have, even though we are still small, but we have quite function that quite discrete from each other. So we have endless of meeting, of course, but we have our in-house clinicians, R&D department, marketing department, rental department, regulatory and compliance department, and a smaller production and service. So, but now maybe only 1 or 2 people in each department. But this is already a lot of work, and they are busy all the time. So this is one of the things that we spend a lot of time in. We believe the product we are making, if it is not supported by strong clinical evidence, it's not going to sell. So this is the first clinical evidence we got. We have 2 subjects. So you see, FMA is Fugl-Meyer, one of the standard tests for upper limb function. So you see, we got an improvement from the different part of the. So funny thing is we can see because this is a measure and the measurement is divided by module. So wrist and hand is it's one set of tests, and they separate it by the grip and pinch, and we can see improvement from all these aspects. And then we extend this to another single case. So 8 chronic patients range from the 28 to 67. This is nice. I remember this. So they have also a different duration of stroke, time after stroke. So when we if you're unluckily getting a stroke, first place you are going to take to is the A&E department, the emergency department, and then you will be wake up, and then you may stay at least, I think, 1 week or so, 1 week or 2 weeks in hospital. That is the time that you are still woolly, and then maybe this is not the right time. Rehabilitation intrude in, but since after 2 weeks, after you wake up, we can already do something, even in the ward. And then any patients they have a stroke for 3 months, that we call it the acute stage, and from 3 months onward, we call it a chronic. So the patients you see here, they all recover from the inpatients, from the hospital. We collect them from community. So we recruit them through the newspaper, and range from 3 years to 14 years. So there are also something about the age of strokes. If you don't move your hand for 1 hour, you may feel tingling. But if you don't move it for 1 day, 1 month, 1 year, there will be some physical changes. So some musculoskeletal change. So the tendon muscle may be shortened, and there will be some contractures. That is the case happening in the 14 years. When we received this old lady, the second one, and then his hand is so deformed, and but you can still move it, shorten it a little bit. So these people they spend time to massage and do acupunctures and do a lot of things to maintain the hand's flexibility. So we put on the hand, ask him to do some movement. But after 8 weeks, this is the guy that he got no improvement. So you see these figures, it is of course statistically significant for as a whole. But there are some people, that is the second case, falling on the lower extreme of our standard deviation. And I asked him, are you disappointed? Because all other people you see, they improved. And then he said, not at all. Because I learned how to relax myself by using the hand. So we believe this is a hand that can indicate the improvement. And also there's other evidence. If you're interested, you can go to the link. So I'm only trying to show it is a project that put together electronics, data processing, signal processing, of course a lot of mechanical things, and some clinical data, but that is an ongoing process. So many things to do. And this is kind of promotional. So advantage now for the Hand of Hope, we are having, besides this, we have a support, and the support is having an optical sensor, so we understand where the hand is moving. And we will use this action, the trajectory of the movement and also the opening and closing of the hand to control the game. So this is the we because the patient need to do it for a long time, like several months, and if you asked her to do only open and close to her ball, and that's why we put funny games. And when you got time, please go to hall 2 again. You will see you will see how this game works. And about my company, so this is the milestone of the company. So it is a company supported by Innovation Technology Fund (ITF), and it is a project. We cooperate with Hong Kong Polytechnic University, and in 2010 we licensed it out, and we found this company. And 2012, we take this project to Geneva for the International Exhibition for Invention, and we are the first company in 40 years to get the Grand Prix. So you hear maybe other company also getting this award, but we are the first company in Hong Kong getting this. So this is a big thing to the company. And then later we got also other awards. We attained also ISO 13485, which is the ISO standard for medical equipment. And then the 2013, we got the Hong Kong Award for Industry. And then in 2015, my company, I am the founder of the company, but now 53% of my company has been acquired by Winston Medical Group. So it is a Hong Kong listing company, 1612. And then just end of last year, we launched the Hong Kong rental program. So for me also, personally, I get the Outstanding Alumni Award for Hong Kong Polytechnic University, and also the Hong Kong's Spirit of Hong Kong's Award for Hong Kong Spirit. So that is what my company is doing, and thank you for your attention, and thank you for the invitation again.